Alright. I think I'm gonna start doing the live stream right now. So, I didn't really make a notice till last 30 minutes, so I don't think nobody's gonna come here tonight, so I'm just gonna speak to myself. Okay, so this is tutorial live stream for Houdini, and this is a 160th episode. One day late, but most of the time I'm doing this weekly. Okay. Alright. And the topic for today is to create more of a pixel art generator system or setup on Houdini using Copernicus COPS network, the new COPS network. Okay, and yeah, previously I have done one tutorial live stream using creating pixel art generations, but that time I was using meshes instead of like Copernicus or but since the new Copernicus is pretty flexible to use, and it's pretty similar to how you create shaders and stuff, so I thought it would be a good practice for me to use Copernicus to do a pixel art to be able to implement the same things on shader language like GLSL. Okay, so that's my intention. Okay, so, and this is the one that you're seeing right now is the goal stuff that I'm going to create today. So there are a bunch of parameters I am going to implement. One is obviously the resolutions. You'll be able to change the resolutions of the pixel art. You could also change the color palette for the art. You can download the pixel color palette from the website that I'm going to mention, and you can just import the files to be able to apply it as a color palette. Okay, so yeah, and the other part, let me choose the one that has many colors like this one or this one. So the other option is to change the background color. You could also change like the colors, and then it's gonna be quantized using the palette that you're importing. So you could also change the color, background color like this, as well as changing the outline color, which is currently drawn as white color, and also a inner edge color, which is currently drawn as black. So if you want to change the outline to black, then you could change this color. If you want to change the inner edge color, then you can change this to white. And you could also change the opacity of the outline edge. If you make it 0, it looks like these. You can also change the opacity for inner edge as well. So that's pretty much it for the parameters, and I'll show you how I created this setup. Okay. Hello, cool VFX. Thanks for the question. Before we start, could I ask question? Do you recommend set 9995 WX for Houdini lows 6096 cores, or still could get less cores and bit faster? Well, I guess you're talking about the Threadripper, I guess. If you have a budget, I mean, I would get it, especially when you want to deal with the PDGs and stuff. But yeah, most of the time I wouldn't need that power hose, I guess, unless you're doing a like top network stuff in daily basis. Otherwise I'll stick to the more I don't know, power more weaker CPU is fine. That's what I would think. But if I have a budget, then yeah, I'll definitely get it. Wow, that sounds really cool. Well, I'm kind of jealous of you then. Yeah. Nice, nice. Yeah, definitely it's worth it, I think. Especially for Houdini, you could use the potential of those CPU. Okay, so let's start. I will, as always, start from scratch. Okay, so starting off, I'm going to create a geometry node, and before getting into the detail, let me just show you the website where I have downloaded. I mean, it's not that complex stuff. So if you go to a website called LoSpec, there you could download a bunch of like color palettes. If you go to the palettes tab, search, and I think it's a community-based palette references where you can download a bunch of palettes made by a community, and like these stuff. I mean, sometimes it looks like a Game Boy Color. Sometimes it's related to like my SNES colors and stuff. There are a bunch of nice color palettes there, and what I am going to use is this PNG image 1 by. This is this is the image when the height pixel is 1 and the width is the number of colors, which is pretty simple to use and pretty easy to use in Copernicus. So that's what I'm going to use as a format. Okay, and the number of colors doesn't really matter. You could choose any number of colors for a reference. Okay, so keep that in mind, and let's do this. Okay, so first of all, I'm just going to create a simple scene with different colors and textures for an actual pixel rendering. So let's do this. You don't really need a high CPU or GPU for this one because it's pretty simple visualizations. Now keep in mind that you cannot use a Houdini lightings like environment light or directional lighting, so it's better if you keep the shader to disable lighting so that you could see the actual like color for each object, which will be used in the Copernicus directly. Okay, so let's have box, torus, and some test geometry like rubber toy combined together. Let's place all these in an array. Okay, let's place these like this. Doesn't really matter how it's been placed. Just wanted to show a different type of topology. Sometimes it's pretty simple. The edge is straight. You have a hard edge like the boxes. Sometimes you have a bit more smoother edge, and sometimes you have more complex edge like these one. which you could have a mixtures of inner edges and outer edges in many places, and so on. So these are good for testing different situations for renderings. Now let me just save this to the current folder. Okay. So now next I am going to set the color for each object. Boxes for a single color, like could be anything but like orange. For the torus, I'm gonna set it to magenta, yes. And for the rubber toy, I'm just going to use the original texture color. Although in Copernicus you cannot, I mean you could, but it's a bit difficult to get the texture informations from the geometries. So instead I'm going to transfer the texture color into a color attribute to the vertex color attributes. Okay, so I'm just change this to a vertex color. And for the rubber toy, I'm going to transfer the texture color to a vertex color. So to do that, I'm going to use a vertex wrangle. And the rubber toy already has a UV value, so I'm going to sample the color using these UV value in Vex, using Vex. So the function that I'm going to use is color map, which you can sample the color from the textures using the UV input UV. Now I don't really know where the texture is yet, so I'm going to make it as a parameter, string parameter, and the UV itself is v at UV. Now the result that I'm gonna get is the color value, so I'm gonna apply this as a CD attribute in the end. Okay, now we need to know the texture path, so we go deep inside the test geometries. We should see the sub network, and on the toy shader on the texture tab we see some textures being referenced here. So I'm just going to copy this one, then paste it here. Okay, as a result, the color must have been transferred to each point as a vertex color, and now I could delete the material informations from this rubber toy, and you still see the color on the mesh, which has been transferred from the textures. So this is not the texture, but it's the color informations. So if you override with something like this, it just disappears. Okay. So everything's good. Now I'm going to import this on a Copernicus, but before doing that I need a bunch of informations on each points, so let's have those informations beforehand. I'm going to make the resolution of the torus a bit more higher so that it'll be more smoother. Okay. Now, first, the information that I need is a normal, which I'm going to use it to draw a inner edge as a pixel. Okay, so normal, create a normal as a vertices. And next, I am going to create a depth informations from the current camera to, which is just the distance from the current camera to each point. Okay, which is, I don't really have a camera yet, so let's create one. So create a camera, and let's get these translate informations, which will be used to calculate the distance from the camera to each point, which I'm going to use it as a depth information, sort of depth informations. Okay, so I've just copied a camera translation information, and I am now going to use a point wrangle, and then let's say calculate depths. Okay, now first of all, the cam position. I'm going to create a vector parameters and paste the camera positions right here. Then you could calculate the distance between the current point position and the camera positions, which could be set as a depth. Now there is another way to get the depth informations on Copernicus, and I'm going to use that as well, but for this one, the reason why I'm calculating the distance on Vex is to check the maximum depth, the maximum distance from the camera to the point on the geometry. Okay, and to get that informations, you have to add this distance value to then a point attribute. Let's check what is it like. So the maximum is like 9.16 and minimum is 5.73 or something like that. Okay, now I want to know the maximum, which currently is 9.7 somethings. So let's get that by attribute promote, and promote the distance value from point to detail as a maximum value. This way I could use this maximum value to normalize the depth value, to be able to normalize the depth value in between 0 to 1. I think the depth value you got on Copernicus is also the distance from the camera. And in order to normalize that value, I think it will be easier to have something like this one, the maximum distance from the camera, so that you could just divide the depth value by this maximum value to be able to get the normalized value, which will be pretty useful for depth estimations. I mean, depth utilities like estimating the outline and so on. Okay, so that's one thing you don't want to do. Another thing, you might also want to calculate some lighting, maybe a directional light, a point light, or anything. But I think you might want to have some shadings to the geometry, not just a flat color, but some shadings, so that the final output will be a bit more prettier. So let's add some custom lights, and I'm going to create an attribute which will be used inside a Copernicus, which can be treated as a shaded information. Okay, now let's first create a lighting direction. This time I'm just going to create a directional light information. If we have a huge object, for example 1 kilometers, and camera really close to object, is it really works? I am not sure. I haven't tried it. It might not work, so we just have to try it out. In that case, we need to kind of make a threshold by yourself, custom threshold. Like the range is from, just like you do for cameras, near clipping and far clipping, you might need to also set your own clipping distance for near and far. But for now, let's try. Okay, so what was I? Lighting direction. Okay, so let's say -1, 0.5 for x, 0.2 for x, 0.2 for 0.3 for z. Now let's normalize this first. Then let's calculate the dot product between the normal informations and the light directions. Now the normal is currently applied on the vertex, so let's change this to vertex triangle. Then calculate the dot product between the normal and the light direction. Okay, now let's apply this to a attribute as is. I might want to make it normalized. I don't know. Currently the dot value is in between -1 to 1, but it might be better if I change this to from 0 to 1. So let's do that like this. Okay, if you want to test it, you could just multiply the current color by this dot value to see how. Okay, it's other direction. You have to make the light direction negative in this case. Okay, so a bit warmer shaded color has been created by multiplying the dot product and the shaded color. Okay, so try plus this value. Okay, if I try adding, okay, so it gives you a bit whitewashed color. Looks a bit more pastel-like shaded. Interesting. For now, I'm just going to go with this. Okay, and what was I don't. Okay, well, maybe I can just bring the color like this and as well. So multiply the dot value to a color and use this on Copernicus straightforwardly. Okay, so that's fine. Okay, and let's connect this to a null node. Let's call this out so that it will be easier to reference this node as a final output on Copernicus. Okay, I think we're ready for a setup on the geometry side. So let's give a cop network and try to render this as a pixel image inside of Copernicus. Okay, so before doing that, let me go back to the camera, and I'm going to use this resolutions as the final output resolutions for the Copernicus. So this will be used to define how high res the image is. So since I'm going to create a pixel art image, it will be easier to see the effect in low res. So I'm going to go with 200 by 200 for now. Okay. Okay, and anything else? I think it's okay for now. So let's go inside a Copernicus network, and first thing to do is to get the current geometry informations in this camera angle inside a Copernicus. So first thing first, SOP import, which you are going to select the alt null node to be able to import the geometry itself. Now I'm going to make this as an image by changing this geometry to rasterized image using rasterized geometry. Okay, which will create an image from the geometries. Now I also have to define the camera informations to this first input. So let's also import the camera import, and select the one that you have created and connect it here. Now I'm seeing a alpha channel of this geometry, which is shown here. So as a default value, you get alpha channel. Now I do want to have multiple number of informations from this geometry, so let's get all of those. The one that I would need is normal, depth from eye, and do I need UV? I don't think so. I have a additional informations which is called a dot val. Oops. Dot val, which is a float number, and I guess that's pretty much it. Yeah, and let's also get the color. Do we have a color? No. So let's get the color informations as well. Okay. So let's check each one of those outputs in null node if we are getting the right value. So this is alpha channel. Let's call this alpha. So I'm just using a null node to preview each one of those outputs. So this is normal. This is depths. Oops. Now, things that I want to check here is that this is the depth informations, but I want to check if those value, each point, each depth value in each pixels is within the range of from 0 to 1 or within the range from 0 to 9, just like what we saw last time, which is the distance from the point camera to each point on the geometry. So in order to check that, I'm going to visualize the COP network result as a volume. Currently this is a volume informations. And let's check the pixel value, the depth value itself, to see the range just for testing. Okay, just to make sure if it's to check if it's a normalized value or not. Okay, and in order to check each point informations on the volume, I guess this is not a straightforward way, but I will name the volume as some density or something. Then get that information on the volume wrangle, create a point on each voxel positions, and set the density value to each positions to check the value. And if I look at this value, the maximum value is 7.13 Let's also check the maximum value of the density calculated here. And 7.59. So there are some gaps, but it's close enough to what we have it here. Since we don't have the backside of this geometry, so it should be less than the one that we got here. So I guess this, from this information, we can assume that the density we got from rasterized geo is a not the normalized value, but the distance from the camera. So for this depth informations, it will be better if we could normalize it, meaning make it a range in between 0 to 1. So that we're going to divide the value by the maximum depth informations. So I'm going to use a multiply. Then for the FG, I'm going to use a constant value. And then for this value, I'm going to bring up the detail information stored inside this out node. So I'm just going to use expressions 1 divided by detail out max d. Okay, and I have divided this value by 1. So I have divided 1 by this value so that you could multiply to make it look like a division. Okay, now the value has been multiplied, and I think the range has become in between 0 to 1 at this point. Okay, so and it will be a bit easier to treat in this case, in this way. In the later process, which I'm going to use OpenCL. Just a reminder. Okay, another null node. Let's check the dot value. There's more of a lighting informations. Okay. And let's just call this dot, or I don't know, light maybe. Okay, another one. CD. Okay, so this, and I guess this CD will be the main image to kind of convert it into a pixel pixel image. So let's use this image as a main for the later process, which is in this case a OpenCL process. I'm going to write all the process for the pixelizations inside this OpenCL. So let's call this pixelization. Okay. Now I do have a bunch of images, so let's create a inputs for all these images to be used inside this OpenCL node. So going into the signature, the source is the original, like the main image, so I'm gonna connect the color value, and that will be RGB, so I'm gonna set it to RGB. The destination is also RGB, so I'm gonna set it to RGB. Now I'm going to, I need to add 4 more images, so I'm going to create 4 inputs. Then for each one, I'm going to name it as alpha, which is a mono, depth, which is again a mono informations, light, this is also a mono since this is a grayscale, and normal, the normal information is a vector value, so that's RGB. Okay, so now we have 1, 2, 3, 4, 5 inputs. let's connect each one of those to a corresponding inputs. Color comes to the source, light comes to light, depths to the depths, normal to here, and finally alpha here. Okay. Preferably, I think you also want to bind it right here, write the bind text right here for each input. I'm not sure if it's a mandate, but let's do that just in case. And also define the size of the type of the value that I'm going to get. And spell mistake. Okay. So bind alpha, bind layer depths, that's also float, bind layer light, that's also float, and bind layer normal, that's float 3. And for the source, that's float 3 as well. And destination value is also float 3. Okay. And yeah, should be good. Now, what else do I need? I think I also need a color palette informations. So let's get that as well. Yeah, float 3 is a vectors on OpenCL. Okay, so let's use file. And I'm going to choose one of the pixel art palette downloaded from the website that I'll show you to here. I'm going to choose Resurrect 64 1 by. So this is the like a strip of colors. In this case, we have 64 colors, so you have 64 pixels in a width as a width. Okay, each pixel has its own color. And I'm going to connect it as a to a null node. Let's call this palette. And should import the file as RGB instead of RGBA, since I just need the color information. I don't need the alpha channel. And let's have another input called palette RGB, so that we can use it to recolor the rendering image. Okay, looks good. Now let's also change the camera option and change the export view continuously so that it will smoothly change the view while I change the camera. It also follows dynamically. The camera also follows dynamically with that option. Okay, looks good. Now let's start writing the code for OpenCL. Let's go one by one. The first thing that I would do is to one thing you would notice when you make the camera resolutions really low, like 100 by 100, the result you see as a Copernicus image looks a bit blurred, which is a bit hard to see it as a pixel image. So what I would do is to use a resample afterward. And just by scaling this like by 5 times or 10 times, doesn't really seem to with a point filter, it will look more pixelized as a final stuff. So I would suggest doing that as a post process, which is just raising up the file size, I mean the pixel size, the resolution of the image. So previously it was 100 by 100. I have just scaled it to 500 by 500 in this case. But in some cases, if the original image is already really high, like 1000 by 1000, making 5 times bigger is a bit too big as a final image. So let's reduce this based on the current resolution. So to do that, I am going to refer to the current camera width, copy that, and come back here, and let's say I want the maximum width of the width to be 2000, and then divided by the current width of the X resolutions of the camera. Then using something like ceil to make it the float, the integer value, which will automatically calculate the corresponding scale value based on the current camera width, and always make the width close to 2000 in the end. So in this case, yeah, 2000 by 2000. And even if I change the camera size to 400 to 400, the final image size is still the same, like this. And the scaling has changed a little bit. Okay, so that's a bit of a tip on when you're using Copernicus for pixelizations. Okay, so 100 by 100 looks okay. Now the first thing I would like to do is to quantize the image color with a palette information that I have here. Okay, so what I'm going to do is to replace the current color on the renderings on the image that I have on this Copernicus. Oops. Replace these each pixels with the one that's close inside this palette. So meaning you're going to limit the number of colors used for final rendering into 64 colors. And if you change the palette, then you can reduce the numbers to 8. Or if you want to have the whole like 256 or 60,000 colors, then if you import that palette, then you could also just use the full color as a final result. But for now, in terms of the pixel art, I think reducing the color makes more sense as a final style. So this is the way that I'm going to do. So choose the palette you like, and I'm going to look for the closest color for each pixels on the image, and replace with the color you have on the palette. Right. So let's do that. So the sample, the palette, I haven't created the bind yet. So layer, palette, float 3. So the palette can be accessed using palette like this. Now what I want to do is to check the current color informations, which is coming from the source, and calculate the distance between this color and each pixels on the palette, and just get the shortest distance color, meaning the color which is close enough to the original. I can do that by creating a for loop through all the color informations on the palettes, which is the palette has informations like X res. This is the width of the palette, which is in this case 64, I think. So I'm going to loop 64 times and check each color on the palette. which is this one. Palette is the color itself, color information itself, and I wanted to calculate the distance between the current point color, which is a source. Okay, so to calculate the distance between the source and the palette, I'm not sure if the OpenCL have a vector distance function, so let me check. Let's see, just Google if there's a distance for the float3, and there seems to be a distance functions for OpenCL. I'm not sure, this is AI, so I cannot really trust it. Let me see. Okay, so there it seems to be a distance function, so maybe we can actually use that. So let's try. Distance between the source and the palette, which will calculate the distance between two colors. Okay, ooh, what's happening now? Seems to be a bit slow. What's happening now? Oops. Oh. I think it's freezed. Okay, can you hear me? Or is it all freezed? Shoot. Let me know if you can hear it. Or is it just... Oops. I think I've done something wrong here. Well. I think I need to restart. Force restart. I am very sorry. My PC has crashed somehow. Sorry for that. Let me set it back. Okay. Somehow I think I done something wrong with the OpenCL code, so let me just check the original code that I wrote, and just to make sure that I'm going to do the same mistake again. Okay. Alright, well, I'm not sure what went really wrong, but let me just check. So for the palette, I am importing the palette, right? The width is 64, which is not that big, so it should be okay to do a for loop. Now what did I really do wrong? Not sure. Or is it overheated, maybe? Okay, well, let me just try again. So where was I? I was trying to refer to a pixel image, right? So let's try doing that again. So let me make sure that I'm going to save it, and first of all, create a loop for palette.xres. I hope this is okay. Yeah, should be okay. Now next, I am going to so for each iterations inside this for loop, I need a UV informations to pick the color for each pixels on this palette. In this case, I'm just changing the U value. I don't really need to change the V value because this is 1 pixels on the height. So let's create the U value in order to get each pixel informations, and that is I plus 0.5 divided by the total number of colors on this palette, which is again AX res. Okay. If you add binder, okay, forgot to do that. Oh, we have it. Good. Thanks for the comments. Design 3D space and cool VFX. Okay, where was it? And so I have a U value, and the V value could be just 0.5. Just get the middle of the pixel. Okay, so let's create the UV value. U and 0.5. Now I'm going to use this to sample the color from the palette. So fill 3 palette color is palette dot I'm going to use a function called texture nearest. Since I am working with the pixelizations, I think I should use nearest rather than sample, which if you use a texture sample functions, you get the bilinear filtered color, which I don't really want. I need exact color, so I would rather choose texture nearest. And UV. So this should create a informations a color informations on each get the each pixel informations for this palette. Now last time I used distance functions to calculate distance between the source and the palette. Now that seemed to stuck, so instead of using function, I'm just going to calculate by myself, which should be cheaper. Okay, so the distance, the color distance is pcol dot x minus source dot x and powered by 2 plus. Now I think I will be okay to just calculate the square distance, because I just need to know the smallest distance information, so I don't really need to do the square root in the last. process. I just need a square distance, and that's cheaper in terms of the calculations. So I'll just use that. So I have added root power 2 of x value difference, y value difference, and z value differences. And that is the squared distance of two colors. Okay, now let's create a max dist value. Start with really high value, like, I don't know, like that. And then create a max index information. Start with, or in this case, should be minimum, I guess. Okay, then check if the min distance is larger than the current color distance, and if so, update the minimum distance with the color distance, and then also update the minimum index to I. And in the end, you will get, actually, I don't really need to use the minimum index, but let's just get the minimum color. Okay, and update the minimum color with pcol. Okay, getting no. The thing with the OpenCL is that it's really hard to look at the error console, so kind of need to find it one by one. So there must be somewhere I did wrong. Okay, it should be this one. No, not this one. Then is this one? No. Is it this one? Oh, okay. I needed to make it float too. Power for gradation? No, it's just to calculate the distance between two vectors. If you look at the distance, if you need to calculate the distance between two, then you kind of need to do a power of 2 for each coordinate. Let me just write it in sketch. Okay, so let's say you have one vectors and you have another vectors. You want to know the distance between these two. Now x has x, y, z, and b has, let's say, a, b, c. And in order to get the distance between these two vectors, what you do mostly is calculating these equations. So this is the distance between A and B. So subtract each element of the vectors, then do a square. And square can be written as power a minus x2 as a function. So that's what I'm doing. And I don't really need a square root in this case because I just need to know which is bigger, which is smaller. The square root is used to get the exact distance from A to B, but I don't really need the exact distance. I just need the comparison informations. So that's the reason why I didn't really need the square root. Okay, so get this back. So no errors, no errors. Okay, looks good. Now, now that I got the minimum color, which has been picked from the palette color, let's override the current source color with this new color. I'm gonna name let's name the final output color as thing col, copying the source. Okay. And I'm gonna replace this source with the thing col. Okay, and finally, I need to output this final color as a destination. Now, in between the destination and palette color estimations, I'm going to update the final color with the one that I got here, minimum color, which should be the closest palette color. If I do that, now the color has been changed to the color picked from the palette. Okay, looks good. Okay, now let's try changing the palette file to a different one to see it affects the current color. Color boy, Lost Century is the name of the palette that I downloaded. A soft sunny days, okay. Oceanic 8-bit. Okay, so looks it's working. So let's make this back to Resurrect 64. We have 60 full colors to render the image now. Okay. Additional things that I want to do to the color renderings. I kind of want to make the highlight using this light information. So let's add some highlight using the same informations got right here. Okay, so let's get back to this. So before changing the current color with the the palette color, let's add some highlight using the light informations that I got here. So how do I do that? I will just actually, the first thing you could try is just adding a light as it is, which didn't work because it's float, the light is float and the source is float 3. So in this case, multiply would work, I guess. Nope, didn't really work. Oh, I forgot to do the semicolon. No, still doesn't work. Oh, forgot to make it at light. Okay, but if you multiply, you're just going to make it darker, not lighter. Oh, okay, so adding also works, but the light currently is pretty much writing every pixels. As you can see, every pixels is more than black, and so it's a bit too bright for the highlight. So let's kind of reduce where it should be highlighted from this light informations. So to do that, I mean, you could recalculate that informations, or you could use something like remap node maybe beforehand and make the input mean to a bit larger value like this, so that you start to have some parts where you want to highlight. And then going back to the pixelizations, you are now just adding the part you only filtered right here as an highlight. So that might make more sense. Okay. As I said, you cannot really use a Houdini lighting system in Copernicus, so you have to create your own light system by yourself. So that's kind of a downside, but compared to shaders, I guess. But that's how it works on Copernicus, I guess. Okay, so that's one way to do it. And I guess it's the most easiest way to do it. So this way I have added the highlight. Remap highlight and a blur on the top would be amazing. Okay. Yeah, you could do a blur in between for sure. Yeah, as you maybe image is better. Yeah. So any process is fine in between these. Okay, so I've added the highlight. Next, let's add a outline to this pixel image. Outline means the outer edge for this geometry, for this image, pixel image. Now, in order to determine where the outline should come, I can use a depth informations right here. Okay, so by using the depths, I will be able to determine where I should create an edge. Now, the main idea is that once you have a image and you analyze the pixels, one on the objects, one on the outside object, and you see a severe difference between these two depths. The pixels on the objects has higher depths. The one that's on the background has a less depths. If it's just a background, it's black. And even if you have multiple objects aligned and it seem to have some different objects behind it, you could still compare two depths between the one on the one objects and one on the different objects, and you should still see some severe depth differences between these two. So comparing these two depths will be able to get you a outline information where the outline should be placed. So let's try doing that. Okay, so the depth is stored coming from this depth input. It's the float value. So you get that. Now let me just make a comment. So this is a color from palette. This is a highlight. Okay. So I think for the outline, I should do this beforehand, maybe after the highlight. And since I want to change the color of the outline based on the palette as well. So let's draw outline somewhere around here. And for starters, let's try to draw the outline with, in this case, the background is dark color, so let's draw it with white color. Okay, so outline color is white. 1.0, 1.0, and 1.0. Okay. Edge detect, it is perfect outline overall. Is it possible quicker per object too as well? Per object is also possible if you create a individual objects IDs, individual objects imported in Copernicus, you could do that as well. Yeah. So yeah, as long as you import individual objects individually inside of Copernicus, you could also do that. I think it is neat to fill black colors and bring back original values. Okay, so the one that I'm going to do here is more of a post processing using the overall depth informations. So it's not really perfect, but we'll do a job. Okay, so first of all, let's get the depth informations, and you also need to get the depth informations on the neighbors. Okay, the horizontal and vertical neighbors. So first thing I would like to do is to create a neighbor informations. So let's create a offset vectors, the offset and a UV direction. I just need 4 vectors. One goes to top, one goes to right, one goes bottom, and one goes to the left. So float 2. Let's first create a bottom direction vector value. Another one, x direction, meaning the right direction. Another one. The order doesn't really matter, it just writing as I talk. So this is a top direction, and finally left direction. Okay, so I have now 4 vectors, vector 2s, to be able to define which is the neighbor direction. Now let's use this informations. Let's call this neighbors. Okay, so using this, I'm going to try to write the outline. So I'm going to make a loop for all these 4 neighbors. So I'm just going to hot write 4 as a loop number. Okay, then let's create a UV value. So UV, in this case, the U can be calculated with the IX, that this is the X index plus 0.5, so that the UV value will be placed in the middle of the pixels, then divided by a X res in order to normalize the value, the whole value in between 0 to 1. So IX is more like an index value start with 0, incremented by 1, so 0, 1, 2, 3, 4, 5, and so on. And XRes is the total number of pixels and the width direction. Same for the V, IY plus 0.5 divided by float Y res. So this is for the V value. Now let's create UV using float 2, combining U and V, and then we could then use this to get the the neighbor informations. Now for the neighbor informations, we need to use these value, the offset value, to offset the current UV to right, left, or top, or bottom. So let's do that. And to do that, we need to, I guess it's better we do it right here instead of doing it right here. So in this case, I'm going to add a offset. Oh, oops. I should Let's call this offsets. So offsets I dot x. So I'm just adding to this value. So this is either 0, 1, or -1. Same for these. In this case, y. And then you'll be able to get a normal, the UV value for the neighbor pixel. Okay. And then we could use this UV to sample the color, the depth informations on that neighbor pixel. So the neighbor depth is equal to the depth map coming from right here, dot e texture nearest, just like we used for the palette, using this UV. Okay, then we should be able to get the neighbor informations, the neighbor depth informations like this, and the current neighbor information is just at depths. Okay, and then what we want to have is the differences between these two depths. So I'm going to use the fabs, the absolute value of the n neighbor depths minus the current depths, which will give you a difference between two depths. And if this is small enough, which means you're on the similar surface. If the value is far enough, then the geometry might be disconnected or a bit far away. So that's what you want to check right here. The threshold value is a bit difficult to assume the right value. It really depends on the lengths, the size of the geometries and so on, but for now let's go with the hard-coded value. You could parameterize this, or you could kind of estimate it by yourself, but for now I think we can go with the small number, the assumable numbers since the geometry is not too big, I think. But we'll check with the different sizes. So if the depth, let's call this the depth diff. If the depth differences is more than, let's say, let's start with 0.02, then we could update the fin color with the outline color, meaning override the colors on the edge where you have a high depth differences to this outline color. Okay, now that does seem to work, but you have like 2 pixel at 2 pixel width for the depths for the outline, which is a bit too thick for this one. I guess I just want to have a 1 pixel outline for this process. And this happens because you are checking the left hand side and the right hand side on the same time. You're also checking the bottom and the top on the same time. So with this conditions, you are kind of mandatory to get the 2 pixels outline. Although by adding additional conditions right here, you could reduce it to 1 pixels, which is to limit the creation of outline based on the depths, the comparison between the depths and the neighbor depths. Let's say you only want to create the outline when the depth is bigger than the neighbor depths. That way you should be able to create just one side of the part to make it as a outline. And this is it. There you go. You have now created an outline with 1 perfect pixels. Hello, Tony Bratisevich. Brating Civic, thank you for the super chat. Hey, do you think it is possible to do sprites instead of pixels in a similar way? I'm not sure about the sprite, I don't know how it works. But, I mean, the algorithm itself is versatile. I mean, you could use it for any purposes, I think. Could be used in shaders, could be used in maybe in Photoshop or Illustrator as well. Okay, so there you go. You have kind of a perfect pixelized outline. And let's try to change these threshold, something like 0.01. You start to see more outline being drawn if this value is really small. If you make it really big, you start to see less outline created, meaning you can control these values to kind of assume where the depths, where the outline should be created. Currently, as you can see, there are no outline being created in between the objects on the front and the objects on the behind, which in this case I might want to have it. So in that case, you might want to lower the value, something like 0.025, and there you're going to have some outline between these two objects. Okay, so changing these values, you could kind of create a different type of outline based on the depths. In this case, 0.03 might be okay. Okay, now let's try going back to a camera view and change the size, the resolutions, see if it still works. Yeah, still seems to work. Okay, looks cool. Alright, so in terms of the outline, it seems to work. Now let's go back and be able to change the color of the outline itself. Currently, I have hard written as white here, but could be better if you could parameterize this, if you could control it from the outside. So let's do that. I'm going to add another layers for the OpenCL value. So let's add two inputs, one for the outline color, one for the inner edge color. Make it RGB for both of them. Okay. Okay, let's go back and add the bind here. Bind layer, outline col. 43. Was the name correct? Outline col, yeah. And bind layer inner col float 3. Okay, now let's create two constant informations, one for the outer color. Let's start with selected RGB, and let's start with something like blue. Let's also create the inner edge color, which I'm going to create later. Let's call this black for now. Connect this to a null node. Let's call this outline col. And let's call this inner edge col. Okay. And connect this to the corresponding inputs on OpenCL. Now you start to have a bunch of inputs. Okay, now for the outline color, you just need to replace this with the outline col right here. So just replace it. And then you'll be able to use this color as an outline color. So let's try changing dynamically. Oh, it's not working. Something must be wrong. Okay, outline color, float 3, signature. Let me just check. Outline col. Is the spell correct? Yep. And I have placed this here. Currently it's white, but it's shown nothing. Okay. Oh, I shouldn't write it like this. And I should have used at mark. Okay, my bad. I always forgot to use at mark. Okay, now you should be able to change the color of the outline and then replace it with the color palette color. Okay, seems to work. Okay, so that's it for the outer edge. Let's go to the inner edge now. In order to see the difference between the inner edge and outer edge better, I should hide the outer edge temporarily. So let's add additional parameter to be able to change the opacity of the outer edge that I have just created. So I'm going to create a float parameters for this OpenCL. Let's go to the binding tab, add one. Let's call this outline opa or outline strengths. And let's make it float. The value, let's start with 0.5. This looks like a string. Let's just call this outline val. Okay, so this is a float, and I can access to this binded float value by add outline val, and I want to use it as a opacity for this outline right here. So in order to do that, I'm going to use a function called mix to mix between the current final color image with and outline color using the outline val. Okay, this way I could use the float value applied here to mix between the original color to a outline color in between 0 to 1. Right? So let's go with 0 for now, because I want to test the inner edge this time. The inner edge is a bit tricky because you cannot, I mean, you could use depths, but for example, if you want to add an inner edge right here, it's a bit hard to determine this part just by using a depth, because the depth between the color right here and the color right here is pretty much the same. So instead of using the depth informations for the inner edge, we're going to use a normal informations, which, as you can see, I see a big difference between these two faces, between the two neighbors where you want to have an inner edge. Okay. Same things if you multiply by think outline bind. Yeah. You could just multiply the bind value, outline value as well. I think it just this way is just looping between this color and this color. If you multiply it, it will become darker. So if you want to use a original color, custom color for this outline color, maybe using mix is a bit more flexible, just compared to just multiplying it. Or you could add, yeah. or you could just add it, like fincal plus outline color multiplied by outline value. That might also work. Let me just try. This gives you a bit different color, but let's see. So if I increase this value, so yeah, it's pretty much the same, pretty close. Okay, so either way is fine, I guess. I tend to use mix because it's a bit easier to predict the result. Yeah, you're right. Okay, so let's go for the inner edge. Now let me go back to the outline value and make it 0. And let's start creating an inner edge. And as I told you, you need to use a normal informations in order to determine where the edge should come. So let's do that. I will draw the inner edge before creating an outline, because if the inner edge and outline edge is on the same positions, I might want to override the inner edge with the outline. So I'll just do it beforehand. Okay. So for the inner edge, same as the outline, I want to look for the neighbors and check the normal values between all the neighbors and the current normal value. So I'm pretty much going to do the similar things here. And let's just copy all these stuff here. Yeah, and this time instead of getting the neighbor depths, I would like to get the neighbor normal. So neighbor normal, get the normal, what's the name? Normal textures, sampling the normal the neighbor normal values like this. Okay, now what do we need to do next? Now, in order to compare between the current normal and the neighbor normal, the things that I want to do is to calculate the dot product. And if the normal is close enough between two vectors, then the value will be close to 1. And if the value is far away, then the value becomes smaller and smaller. So we could create another conditions like that. So let's calculate the dot product. Float e dot val is dot between the current normal and the neighbor normal. Okay. Now, what we want to check is if this dot value is smaller than some value, some threshold value. Let's say start with 0.9. And then let's try replacing the final color with some custom color. In this case, we already have inner color attributes, I mean the inputs. So let's just use that. Oops. What did I do wrong? Let me check. Oops, it should be dot val. Okay. Okay, now as you can see, I start to see some edges. Let me change this to white. And there seems to be a bit issues with there and there, and one issue that I see is that background color is being replaced with the inner edge color, so we need to fix that. And I realized that I don't really have a background color info, because the black is just a alpha channel color. I mean, alpha is 0, it's just a transparent right now. So let's also make sure that we could also change the background color for this setup. So I'm gonna create another constant. Let's create a null node and let's call this background, so that we could also change the background color. So let's set this to RGB, change this to some, I'm gonna start with the purplish color, like this. And let's connect this to a OpenCL, meaning I need another bindings, layers. Let's call this BG, RGB, and connect this right here. Going back to the code, have BG as a value. Okay, now we kind of know where we should put the background, because we have this alpha channel informations where the alpha is 0, meaning if the value is black in this image, then that's where you should have the background. So it's pretty easy to determine where the color should be a background. So let's go back to the pixelization and create the conditions before the inner edge. If the alpha is less than 0.01, which means it's pretty much close to black, then use the update the final color with the background coming from here at BG. Else you can deal with the inner edges. Okay, let's check and let's try changing the background color, see if it's working. Okay, yeah, it's working. Now we can start to deal with the inner edges. Okay, so right now the inner edge looks a bit thick on some places, and you also seems to have some edges on the outline as well, which is not really good. I just want to have it as an inner edge. I don't want to have it as an outer edge for this function. So we need to add some additional conditions to this in order to kind of limit where the edge should be created. Now one thing you could try is making this value a bit lower, which does kind of reduce where the edge should be created, but it's not really perfect. So let's think what else we should look at. Okay, so one thing we could use is this light informations. Where is it? No, wait a minute. Let me go back to the geometry and what kind of informations I have created. Now one thing I need to have is the informations from the camera, In this case, I want to know if the point which I'm seeing on the viewport is facing to a camera or not. For example, the pixels which is behind this geometry is facing, it's not facing toward the camera, but more away from the camera. But the pixels that I see right here are close to where you're, it is trying to face the camera. It's close to where you face, close to the vector itself is close to when you calculate the vectors from the point to the camera positions. So what I want to do, what I want to have as information is the dot product between the normal for each point and the vector values from point to the camera positions. And I currently don't have that value. So what I would like to have as an additional information to each point is the directional value, going from each point to the camera positions. Then we could calculate the dot product between the normal and that direction. Okay, or I can just calculate that dot product within the vex. That might be easier, so let's just do that. I'm going to use a point, vertical wrangle, vertex wrangle, and I might be okay. So I need a camera positions like this, so I'm gonna copy the vector cam pos. Oops. Copy the same value that I have it here, which is the camera positions, and just calculate the dot product between the normal and the camera positions minus at P normalized, which will give you the dot product between the normal and the vectors coming from each point to the camera positions. And that value could be used to determine if the point is facing front side or back side. If it's negative, it's back side. If it's positive, it's front side. Seeing from the camera, I mean. Okay, let's check the vertex attributes. So we see this dot product. So if it's negative, it's facing back side from the camera. If it's positive, it's front side. Oops. So if we want to check that, we could do that by using color class to vertex, change to ram from attributes, and change this to dot product, and that's from -1 to 1, and change this to infrared or something. So if it's bluish, that means it's negative. It's positive, it's reddish. And that is from the camera. So you can see that if it's facing toward the camera, it's more of a warm colors. If it's not facing its backside of the camera, then it's coolish color. Okay, so it seems to work. So the dot value has been created, and now we want to refer to that information in order to determine where the inner edge should be created. I could use that information to remove the inner edge information from as an outline. Okay, so going back to the COP network, and let's get that dot product informations. Now I already have a dot bal, but that's a different name. The name that I have now is .prod. I should have used a different name, which is mono. And let's connect it to a null node. So this is different from the light information, which I've got from the .val. The light information is dot product between the light directions and the normal. But this one is the dot product between the camera positions and the normal. So it's a bit different. Okay, let's call this camera dot. Okay, and let's add additional input. Now we're going to have tons of inputs here. Looks complex, but not that much. I'm gonna call this cam dot. It's a mono. All right. And let's bind this. Bind layer cam dot float. Okay. Now let's connect this to the cam dot. Okay, where is it? Okay, so as you can see, you are having an outline like these, even if I'm setting off the outline. Current moment, it's called 0. If I increase it, it's replaced with the outline, I think. Let's change the outline color to black so that we can see it. Okay, so as you can see, you do see an outline overlaid with the inner edge, but if I make the outline opacity to 0, the behind color will appear, and I don't really want to have these color inner edge being created as an at the same place as the outline. So let's try to remove that. So going back to the code, and this is where I was creating a inner edge. Now let's call the what was it? The dot product value, which is called as cam dot. Okay, so and let's try to create a conditions using that value. So cam dot, if the cam dot is more than 0.01 or something, so meaning try to reduce the edge where the normal is facing backward, and it's not really working well. If I make it 0, still not. If I make it 0.1, okay, this might not be working that much. I might need to look for use the different kinds of values. If I make it 0.5, if I make it, okay, now this works, but I still have some problems right here. So maybe this condition is not really perfect. Let's forget about it. Okay. Another conditions that I could think of. Now, first of all, the things that I have two edges, like 2 pixel edges on the corner like these, is the same problem with this one. So I mean, I could try using the similar method like this one on the inner edge, but doesn't really work like that on the inner edge, because you cannot use the depth informations in this case, and you cannot really compare the depths. So Things that I am going to try now is a bit different approach compared to the outline. So first thing I'm going to try is to make the offset, make the neighbor offset value for u and v to be multiplied by 0.5. Not here, sorry. Not here, but here. Yeah, wait a minute. Yeah, right here, I think. Is it? No, multiply the offset value by 0.5. That way, you could kind of reduce the inner pixel edge width by 1, but you still see some conditions. I mean, 2 pixels like conditions somewhere like here. So in order to avoid this, instead of adding 0.5 as an offset, I will remove it. That will, that still gives you some conditions. Maybe I'll try that later. Okay. Okay. For now, let's try thinking. Let's think about how we can get rid of the outline first. Okay. So, one thing I could think of is, let's see. Well, since in order to determine where the outline is, we use depth, so I guess we could also use depths in order to determine where the inner edge should not be created. So just as we did for the depths, I'm going to get the neighbor depths as well. Calculate the depth difference as well. Then use this to ignore the outer edge to be created. So in this case, previously I was using this value to create the outline, but in this case we want to remove the outline. So going to create the conditions like this, smaller than conditions. Beforehand we were using a larger than conditions. So there you can now reduce the outlines using depths and only the inner edge is being created. And whenever you rotate it, the inner edge estimated by the normal directions will be created like this. Okay. Now let me check if it's gonna work on every resolutions. Let me try changing the resolutions of the camera. See if it's gonna work. So if I increase this, if I decrease this, okay, well, seems to work. I'm wondering if I could kind of fix these areas. I mean, to me it looks a bit too thick in this area. So preferably I want to fix that. So let's go back and check where I can do that, where I can fix that. Now, if you remove this value, you're going to offset the UV value to 0.5, and that sometimes might work, but it's just shifted the inner edge positions and doesn't seem to do anything as I wanted. If I subtract it, yeah, well, in this case it becomes more thicker, a bit thicker than previous one, so that's not really what I want. Okay, so let me check the conditions, other conditions that I could think of. Okay, so so we have oh, by the way, we could control this value, so that's not it. Well, this is just changing how much inner edge is being detected on the rubber toy, just fine. And changing this is also just changing the outline detection, so not that important. Now, let me check the one that I created previously and what's the difference between that. Okay, so let me see. Well, I might still use the dot product value. Yeah, I might still use it. Let me go back to see how I created the dot product. Okay, so this is how I created, and the value is in between -1 to 1.0, so that's should be fine. Yeah. Let's go back inside the COP network. And so we do have a dot product value here. And maybe I think I also need to check the neighbor dot product. Not this one. Sorry, not this one, but cam dot. Okay. So let's get the neighbor cam dot value, shall we? And let's try to use that as a condition. Okay, so float neighbor cam dot is cam dot texture nearest sample. Okay, and then the conditions that I need for these two is well, it's not really related to the edge on the middle, so I think it's not really important, but let me just see. Cam dot should be larger, as well as neighbor cam dot is larger than 0.5. Okay, nothing really changed, so it's not really important. Maybe I don't really need those. Okay, well, looking at the code that I wrote before, it's pretty similar to what I have right now, so maybe this is all I can do, maybe. Let me see. How I created the UV is similar, yeah. How about changing this value to something like 0.3? 0.4. No. 0.6. Now this will create a thicker. I guess the way it looks like this is correct. Maybe it's really due to the camera perspective. Something. Let me try changing the perspective to something different. Doesn't really make any changes. Or orthographic. It's pretty much the same. Okay, now things happens weird when the angle, the camera angle is like this. You starting to have something like this here. This is due to the error by adding 0.5 to this value, I think. Let's try to remove this to see if we could see some changes. Not that much, eh? Maybe it doesn't really matter. It's pretty close. Okay, well, I don't really see 0.03, you mean this one? Well, doesn't really change that much. I mean, just reduces, I mean, just controls the depth detection, outline detections. So should be small rather than bigger, but doesn't really change. But start to create some weird stuff here. So I shouldn't really touch here. Well, I guess I don't have much things I can do at this point. Let me check here. So I was just checking. There must be something that I would be missing. Let me see. I think I was the way I created the offset, is it correct? So offset it, multiply by 0.5, it's the same as I wrote previously. Yeah, it looks pretty much the same. So I think this is the way I wrote it previously. The only difference is that I set this to 0, but that will just offset, shift the edge positions, and that's it. And if I make this to 1, it will be thicker. That's not really what I want, is it? And I'm using texture nearest, that's also correct. Yeah. Let me think. Well, if I'm going to use a texture nearest, it will be better with these values to be 0. And then make this 0.5. So I guess this is fine. Maybe. I wonder if that's so. Let me change the pixel to really low. And let's see. Well, I'm just checking things right here, which is mostly using normal information right here. And let's see if one of the some calculated dot product between these two, checking. So this is the dot product that I'm checking right here. Normal and the neighbors. And neighbor normal is, I think this is correct. Yeah. Now, well, can't really. Let's see. Another conditions that I could think of is cam dot is larger than neighbor cam dot. Oops. And that is creating some dot like this. Just doesn't really look good. So in this case, maybe I could use 0.5 additions. Not so good, is it? If I make this to 1, looks better. Okay, let me increase the resolutions. Okay, looks better. Yeah, nice, one line, perfect line. Okay, so that was it. So looks the conditions does look different from what I wrote. But this seems to work. So I'm just referring to the cam dot and the neighbor cam dot, and I'm just picking up the higher one, just like I did for the depths, like this. So this seems to work. Good. That's good. Now the inner edge seems good. Let's try to use the inner edge color, which, well, okay, I'm already using it. So I can now mix it with a outline. Let's make the outline back to the action, and both of them are combined. Now let's also add a inner edge opacity as a binding. Let's call this inner edge value float. Start with 0.5. And I'm going to use a similar functions, a mix between the fin color and the inner color using the inner edge value. Okay, now I can control the opacity of the inner edge so that I can remove it or show it with these values. Okay, let's try changing the color. Okay, seems to work. The outline Okay, also seems to work. Okay, so everything's good. So I think I have pretty much done everything that I needed to show for the setup. So I have a pixelized image, pick the color from the palette. I have created the outline with the color. I have created the inner edge with the custom color. I have the background as a custom color. And that's pretty much it, I guess. Okay, so overall, and in the end you have resampled it. And you could save the image by right click the node on the last resample node and save it as a, I don't know, maybe a PNG file. And let's check that. Let's check that. Let me see where the file is. Okay, so today's folder is right here. Okay, so this is the outputted PNG file. It looks really nice. Okay, and seems to work. And now you can kind of play out with anything you want to do, maybe right after merging it, you could try animating it. Let's move this to a center, rotate this. Repeatedly, and you could convert this into a pixel image in kind of a real time, just like you do in shader. And the process that I followed, the one you have drawn on OpenCL, is pretty similar to how you write in GLSL, so I think you could directly transfer it into a shader code. Hi from Crane. Thank you for watching from Ukraine. And thank you for all the comments. Really nice to see it. Okay, so most of it I am done. Let's organize this a little bit so that I can control all the parameters that I have from outside, like using this controller node. So let's create bunch of parameters. Okay, first of all, a camera resolutions for sure. So let's bring this right here. I'm just gonna call it res from 10 to 1000 maybe. Okay, and we have, what else we have? These are pretty much automatic. So we have a light direction. So light direction. Okay, let's go inside a COP network. We have a bunch of parameters we could control. One is the palette file. So let's have that. Okay, one is these outline transparency and inner edge transparency or opacity. So what do I call this? Outline strings from 0 to 1. This is inner edge strings from 0 to 1. Okay, and we have colors we could control. So this is outline color. This is inner edge color. And we have a background color. That's it. You could also parameterize these parameters like threshold values. Right now I've hard-coded, but maybe it might make sense to make it parameterized. So let's do that. So let's see. So this is the depth value. So let's create the bindings, add additional parameter, depth, threshold, float, yeah, 0.03 is the default value. Going back to the kernel, replace this with the depth threshold, also here with the depth threshold. Okay, now 0.75 is to determine the inner edge threshold. So let's also parameterize that as well. Add another bindings, known threshold. Actually, it's a dot product threshold, but it's okay. Let's call this 0.75. Copy it. Replace it. Okay, now let's add these two parameters inside the null node. So I'm just going to bring it here, called it depth fresh, from 0 to, could be really small values of 0.1, could be a maximum. And the another one is the normal threshold. Norm threshold. Actually, I should name it as outline threshold. Could be more easier to determine from the name. So let's have it somewhere around here. And this is actually an inner edge threshold. Come to think about it. Okay, and that's it. That is from 0 to 1. Okay. Let's add the separator in between the inner edge and outer edge. I guess that's pretty much it. Is there anything else that I could add as a parameter? Let me see. Nope. I don't think so. Okay. Other than that, yeah, pretty much automatic. So going back, apply, accept, and now I have a bunch of parameters being listed here. I should be able to control a bunch of images just by changing these parameters. So the resolutions, the light direction. Actually, I could control the highlight. Let's do that later. Outline threshold, outline color, outline strings, inner edge threshold, color, and inner edge transparency and background color, and also a palette file to change the color. This is nice. The one that I like is this one, Lost Century. It's pretty nice. And that's pretty much it. You can also animate this. So let's change the highlight part. Let me make this back to 64 colors, and this is where I was changing the highlight. Especially these remap value will matter. So I'll just make this part, the input min part, to be parameterized. And that's it. I'm gonna call this highlight from 0 to 1. Let's have it as 0.9. Copy this, go back to the copy network and paste it right here. Okay, a bit bigger. Yeah, that's it. This is it. Thank you very much. Yeah, background changes automatically the palette. If you want to have, if you don't want your background to be overlaid by the palette, then you have to have these functions right here on the last before making changing with the minimum color, changing with the palette color right here. So you could just copy this part, place it this, if you just want to have the original background color as is. But it's up to you. I'm just gonna comment this out. Okay, so that's it for today. Thank you everybody for being here, watching here. I'm going to upload the files as soon as I finish the live stream and paste the link to the video description part of this YouTube live stream. I will also upload the files into a Patreon page, so you could come to that page to download the files as well. Yeah. Well, everything is free. Well, if you are willing to donate, then that will be great on the Patreon page. It's up to you. Okay, that's it. Thank you very much for coming, and I'll see you maybe next week. Let me just try with the another palette and I'll finish this live stream. So you can go to the palette, the website like this one, lowspec.com. Like for example, you could choose, let's search for Game Boy. Let's try, okay, I like this image. Let's try this color palette. So this is just full color. Okay, download the PNG. And let's bring that image Okay, let me see. Where is that? It's on the download folder and so this is the image. So this is kind of a blurred, but this is just a full pixel image. Okay, aligned and horizontally. So I'm going to place that in the folder where the Houdini is placed. Houdini file is placed. And where is it? Okay, right here. Then let's import that file. I think I should use this one. And there you go. This is a Game Boy Color theme. Okay. I guess I would rather use this one. A bit more colorized. Or like this one. I think I like this one. Yeah. Anyway, this is the whole setup, and it's pretty flexible to be able to expand it for more other usage. I think you could add like dithering, order dithering or Lloyd dithering to make it a bit more low res image or something like that. By the way, the last question, what is your PC spec are you using? Is mini PC or iMac? I'm using MacBook Pro right now, M3 MacBook Pro on this live stream. For the PC I have Intel, was it Core i9 on my at home, but not that strong as Threadripper. I forgot the model numbers. Maybe that's it, but I'm not sure. GPU wise, I have 4090s on PC. Which is pretty useful. Wow. Yeah, Threadripper, yeah, I'm kind of envy. Yeah, I agree. Okay, thank you very much, everybody. I will finish the live stream for today. Good night and have a nice week. Bye.